What is your name and institution do you represent?
Hi, my name's John Boughton. I am part of Dr. Jim Grinias' research lab at Rowan University.
Yeah, I'm Declan Parker. I'm a PhD candidate at Rowan University in the Jim Grinias lab.
And what's the primary focus of your research?
Specifically on substance use disorder compounds and actually looking at solid phase extraction paired to some capillary LC separations of those compounds.
I work on a custom 2D LC system where we're pushing it down to that capillary scale, trying to do some validations, proof of concepts, then hopefully scale up, work with some MS on it, add some other second dimensions to it, some unique stuff.
So how do you currently use capillary or nanoscale separations in your research?
So actually, basically all of my research actually hinges on capillary LC, where the idea and a lot of our focus has been trying to get it to be more of a point of need setup. So with the advance of certain capillary LC systems, we've been able to essentially point a lot of our research towards that.
What surprised you most about moving to that scale?
Sensitivity and pressure. Just those low flow rates, but needing those high pressure instruments to get up there was definitely something that was new to me. In our experience, we had to go to those high pressures for that high throughput kind of thing.
Any technical barriers preventing these separations from being more popular in the general laboratory community?
I would say general techniques of like understanding plumbings and the importance of making sure everything's always filtered and things like that definitely become extremely important at these smaller scales. So I would say that.
Like any other technique, it is an adjustment. The smaller scale is something that you have to get used to. It's more delicate in the sense of dealing with the capillaries themselves, but it is, especially if you want to work with MS, I think is absolutely worth it. I like seeing, it's a lot cleaner with the MS. You don't get that overflow. I think also the smaller lab bench space. I mean, we are, as an academic lab, we need as much space as we can. It's amazing that I can fit an entire two-dimensional system in like a half a lab bench. So I think that's great.
What remains the biggest bottleneck in analytical science from your perspective?
So I would say the biggest bottleneck generally would probably be more sample preparation, and I guess the technique and really everything related to sample prep in general of how much influence the actual scientist, the actual chemist has on that. I think that tends to be one of the bigger bottlenecks. Specifically, always making sure your solvents are clean, definitely making sure everything's filtered, so if there's any sort of dust or particulate, that's always going to be one of the major things. Anything with samples, making sure those are clean as possible.
AI is increasingly entering analytical labs. What parts of LC and MS workflows will benefit the most, and which areas still require experts?
Sure, so I think for maybe initial development, probably having some sort of expert would probably be good. In terms of optimization, so if I think that sort of thing would probably be better for some sort of artificial intelligence. I think those would definitely be a lot better with that because they can do some sort of modeling and refer to that. But I think generally for initial method development, that would definitely serve better for the experts.
What do you think the big gains you got out of it, from your opinion, moving to that scale?
Oh, I mean, just solvent reduction is just a big one. As someone who doesn't like the prep side of things, I like getting data as much as possible and stuff like that. I mean, we would make solvents and they would last forever. We'd have to replace the solvents because they lasted too long rather than we ran out of them. So to me, I mean, that was always just a very cool thing of that kind of reduction. And then the same with the sample prep, just not needing very much, injecting things like 40 nanoliters, some just ridiculous sizes of things. That was a very cool kind of step back from the larger sample prep side of like analytical scale.